2, 5, 6, 7.
Okay, Otto, this is 3-5. This is proving segment relationships. We should get done with this in class today. Just one day for this section. By the way, 3-5 is halfway through the chapter. So tomorrow, but then you don't have homework over the weekend. Tomorrow we're looking at mid-chapter quiz. Mid-chapter quiz, but you get to use your notes on it. So it's fine. Yeah, mid-chapter quiz tomorrow. You get to use your notes. It's with notes. It's gonna be fine.
There's no review.
No, we'll just dive right into mid-chapter quiz. We did review for trig just because it's such a long chapter.
Is notes.
So then what are we doing on Friday then?
Tomorrow is Friday, darling. Whoopsie daisy. Yeah.
What did you think it was?
Okay, so we're not going to write every single theorem or postulate down that we come into contact with. Like this first one, we're not going to write this guy down, but here's what it says. Ready? I love it. In words, the points on any line or line segment, like this guy, can be put into one-to-one correspondence with real numbers. In idiot terms, this says, if I have a line segment, I can measure it with a ruler. That is the ruler postulate. How stupid. If I have a line segment, I can measure it with a ruler. We're not going to write that down. Okay? Whatever. Okay? That was kind of like an idiot, like, really? Do we really have to put that down? Whatever. Okay. This one we are going to write down. So here is the segment addition postulate, and we're going to put a big old star by him because we're going to use him a ton. But here's what segment addition postulate says, right? If I have a segment and I have 3 dots on my segment, it doesn't matter where B is located. He doesn't have to be the midpoint, right? So we purposely put him off to the side so we know that he's not the midpoint. But this says that AB, whatever that length is, if I add that to whatever the length of BC is, it will be the same as the length of AC. We are adding segments together, 2 smaller ones to make up the bigger one. That should make sense, right? If this is 7 and this is 3, the whole thing should be 10, right? Like that's how that works, okay? So segment addition postulate, that's the first thing that we're going to put on our pink sheet. And whoop, he is, I don't know, right here. Okay, so do you guys have a star by midpoint theorem, the one right above that? Yes, okay. We're going to put a star by this one also. This is theorem 3-9. No, postulate 3-9, not theorem 3-9. Postulate 3-9, P-O-S-T, period, 3-9. And he is segment addition. We are adding segments together. Postulate. Segment addition postulate. Okay. Do you guys want to use ABC or XYZ?
ABC.
ABC? Sure.
Wait, no. XYZ since we already have that.
Sure, XYZ. Okay, so I'll put X here and Z here and put Y not directly in the center because I don't want you guys to be led to believe that this only works when Y is the middle. So put him either to the left or to the right, doesn't matter. Okay, but don't put him dead in the center. I don't want you to believe that this only works when he is in the middle. Okay, and segment addition postulate says XY plus YZ equals XZ. Whatever those 2 lengths in the middle are makes up the full length at the end. That is that. That is that. Okay, not too bad. We can handle that. Okay, we got 1 proof to do, and then we'll write some more on our pink sheet. Okay, good. We ready? All right, so let's go to example 1, segment addition postulate. Here is what we've got going on here. I'm going to go through the given and the proof so we can understand like what we're trying to do here, all right? They are telling me that QT, which is this guy right here, QT, oh, it's cutie, and RV, this guy right here, those 2 little purple pieces, that those are the same, right? They say, prove to me that that means that this little chunk and this little chunk are the same. Okay, now let's see if this makes sense, right? Let's say those 2 purple pieces are 7 units, okay? I'm just going to give numbers to them. We're not going to use the numbers in our proof, but I'm just going to like see if this makes any sense, right? So let's say the first one is 7, the second one is 7, right? Let's say this middle guy right here, RT, is 5. I don't know. How big is QR? How big is this one right here? 2. And this one is also 2. Does it make sense that those 2 outside pieces should be the same if the middle is 5 and then both of them, the 2 pieces add together to be 7, right? Okay, that's what we're trying to prove. right? Like it just makes sense that it's that way, right? But they were trying to prove it, okay? And we're proving it without the numbers, okay? So you can leave the numbers on there if you want to, but whatever. We're trying to prove it without the numbers. So let's go step by step. And they're starting with the given and they write given. That's always how we start, right? We only have one piece of given information, all right? So I'm going to remind myself what we're given. We're given this. Those two purpley pieces are the same. All right, now they give us a little hint. They say definition of congruence. What do I do with definition of congruence? That's one of the things that was on your pink sheet.
Y equals squiggle.
Yeah, so it's going to be QT is equal to RV instead of QT is congruent to RV. It seems kind of silly that we have to do that, but in order to be able to work with like adding them together and stuff, we have to have that their lengths are equal. This means congruent, which is same shape, same size. This means equal in length. So we gotta reduce it down to talk about their lengths before we do that. Okay. All right. Now let's talk about the next thing. There's a colon here, so I'm just going to talk about this first little chunk. This guy in this box, and the guy in the box, that blue guy, says that QR plus RT equals QT. Okay, that's what that first little box says. What did we just do there? What was that? That's the segment addition postulate, right? That's probably what's going to go on this line. Segment addition postulate. Okay, now I'm going to also look this as the other guy because we have another one right here. He's the green one. And the green one says that RT plus TV equals RV. Is that also segment addition postulate? You betcha, right? Okay, so they double it up there so we'd only have to take one line for that because it's both segment addition postulate. All right, now, crap, what do we do with that information? Ooh, okay. Well, I'm going to look at these two lines in combination with each other, right? You see those two, like number 2 and number 3? I have that QT equals RV, but then they tell me, wait a second, QT is this junk, right? Okay, so what if I take that junk and I replace it for QT, right? And then RV is equal to this junk. So can I take that junk and plug it in for RV?
Yes.
Okay, so now I have the QR plus RT is equal to RT plus TV. Yeah? Okay, because I plugged those two bigger chunks into the other one. What's that called? Yeah, substitution. You got it. Substitution. Okay, they say substitution property, whatever. If you want to write property down there, you can. I just put substitution. You can be lazy. That is fine. Okay. All right, now, looking at this guy right here, okay, I want to eventually get to the point if what I'm trying to prove is QR and TV are the same. QR is here and TV is here, and I need to get rid of these middle two pieces right there. I need to get rid of that RV and that, or that RT and that RT. Can I just subtract them from both sides, right? Like a math, if there was 3 on both sides, I would subtract them and they would go away, right? So that's what they're doing in this next piece. They have QR plus RT. We're going to subtract that RT, and RT plus TV, and we're going to subtract RT. Sometimes they write it in there and they write the subtraction property, and then they actually eliminate them in the next step, right? So like this guy, they get rid of those two. This next one, they get rid of those two. So all I have left is QR equals TV. So they wrote the subtraction property here, but what do I write on line number 6? Substitution. Yesterday we talked about how, not yesterday, the day before. The day before we talked about how substitution sometimes is your simplifying step, right? It's kind of weird. Okay, so substitution, we have that. And then to go from equal to congruent, we have definition of congruent. Good? Yeah, not too bad. Okay, that was all right. Okay, that would be hard to generate on your own, maybe. Like the blanks, fill in the blanks was maybe okay, right? Generating that on your own, we're not quite ready for that, and that is okay. Like I don't expect you to generate that on your own. Yeah. Okay. All right. Let's go to the next thing that we're going to write down. And we actually have 3 lines that we're going to write down. Whoop, and these 3 are going to go together. And I'm going to use the same diagram for all 3 of them. Okay, so they're going to all go together, and this is theorem 3.2. So all of these fall under theorem, Theorem, or if you want to abbreviate, you can, 3.2. These are the next 3 little pieces. And the first one is called the reflexive property. This one is the symmetric property. And this one is the transitive. Oh, can I spell Trans? Transitive. Transitive property. There we go. There we go. It's reflexive, symmetric, transitive property. Okay? And then I'm going I'm going to put AB here. These are all kind of like the same length. CD here. EF here. Whatever. Okay, those are the three things that we're going to talk about. Those are the line segments over there. They're all kind of the same length. Maybe-ish. And then we'll write out what these properties are. So I'll give you a second. Oh, that's kind of cool. Did the moms do that for you? That's cool.
We need to put stars by these.
No. Nope. We won't use them quite as much. That was a very good squiggly. Very good.
Yeah.
Look at Allie's.
Ooh, very nice. It's an S and then a backwards S.
So yeah, go.
Yeah,
It's always going on the way back.
yeah. Yeah, mine's kind of messy too.
Oh, I never thought of it that way.
Yeah. He's an S and a backwards S. Uh-huh.
And then
Yeah.
Winston's dad and Owen's dad put up the signs on the highway.
Oh, very neat. I haven't seen those.
Those are cool.
Because this is districts, right?
They have like
Ooh.
cross-country district signs up
Ooh.
on the curbs.
I had a PR by like 5 or 6 minutes.
Woo.
Just even get in top 15.
Yeah,
Be like last place.
yeah.
Do you think,
Rim? No.
what about William? Macy probably.
Who? Lillian.
William?
Who's
Lasser?
He hasn't been running.
Hmm.
Yeah, he hasn't been running.
Pooping in the pool?
No,
Yeah, I think it was
he hurt his leg on something a while back.
probably
Was it
probably
getting
jumping
into
the
the pool?
fence.
Yeah.
Interesting.
No, it was like 3 weeks ago.
Okay, ready? I'm gonna do these three, but I'm gonna start with the middle one first, and we're gonna do the first one last. How about that? I'm gonna do them in a weird order because the reflexive property is very stupid, but it's kind of hard to understand. So I'll do that one last. We're gonna do the symmetric property first. So this one says, like, let's say if AB is equal to CD, like in length, right? Then symmetric means the same on both sides, right? Symmetry, right? Then CD is equal to AB. I can flip them around, right? Symmetry. Okay? You guys have done math problems before where we end up with the answer being like 2 equals x. Don't write that pink part down, right? And does that bother you?
Yes.
So you flip it around and you see x equals 2?
Yes.
The symmetric property allows you to do that. It's what says, hey, that's okay. They're the same. You can flip it, right? So that's what that means. Okay? You don't have to write the pink part down. All right, let's do the transitive property. So make sure that was in the middle one, right? The transitive property is the law of syllogism. Do you guys remember the law of syllogism at the beginning of the chapter? The law of syllogism. If, I don't remember who my people were. Anna, are you older? No. You're the old one, right?
No, I was taken out.
You were taken out. You were the young one. Yeah. You're the old one, right? So Anna is younger than Brady. Brady is younger than Kaylee. So Anna is younger than Kaylee, right? We skip over the middle person. So the law of syllogism says if AB is equal to CD and CD is equal to EF, then AB is equal to EF. We skip over that middle person, right? Or that middle group. You can go from the first to the last one. That's the law of syllogism. It's also called the transitive property.
I wrote the name.
Transitive property.
The little box.
Oh, yeah.
You're just a funny guy.
Funny. Okay. All right, now the reflexive property. This one's the stupidest one of all. And you're going to write it down and you're going to be like, what the heck? And I'm going to tell you why this works, okay? So the reflexive property says
Never seen someone.
AB is equal to AB. That's what the reflexive property says.
What the?
You're like, why do we even have to write that down? Of course, AB is equal to himself. Okay, but let me show you. Ready? AB is equal to AB. We will actually, like in the coming weeks, probably use the reflexive property most often for proofs than any of the other two. Okay, and here's why the reflexive property is used. This is probably like the most widely used usage of him. Okay, so let's say I have A, B, C, D. Do you see my two triangles? I'm trying to prove that this triangle is congruent to this one. So same shape, same size, all right? So what we're going to do is we're going to go about doing that by, I'm going to show that this guy is the same length as that one, right? And this guy is the same length as that one, right? And then this guy is the same length as himself. True?
Yeah.
So what I'm going to do is I'm going to say in my proof that AB is equal to AB. And it's the same AB, but I'm talking about like AB, this length for that triangle versus that length for that triangle. So it's the same AB, but it's different ABs, kind of, right? Does that make sense? Okay, so that's what we do for proof, one usage of the reflexive property. Got it? Okay, so it seems really stupid, like why would we even have to write that down, like AB is congruent to itself? Well, of course it is, but that's kind of like an example of how we would use that. Good? All right, we're done with the pink sheet, but keep him handy. We're done writing stuff down on him. Let's go to example 2. And example 2 is a little bit,
All of this is hard.
he's a little bit more far-fetched than example 1, but he'll be all right. He'll be all right. Okay, he'll be all right. Okay. So example 2, let's look at what we're given and what we're trying to prove. So we are given 3 things, right? We are given that R is the midpoint of QS. And we're given that T is the midpoint of ES. So this is a midpoint and that's a midpoint. Those are the first two things that we're given. That's a midpoint, yeah? And now we're also given this little guy right here. I'm circling him in pink. QR and VT are the same. QR is this little guy and VT is this little guy. Yeah? Okay. We are trying to prove that RS and TS are the same. RS is this guy and this guy. And TS is that guy. Okay? So here's my thought process. Ready? If I know that this guy is the midpoint from here, those two pieces should be the same. If this guy has a midpoint, then those two pieces should be the same. And if these two pieces are the same, shouldn't these two pieces be the same? Because all 4 pieces should be the same, right? Does that make sense? So that's like us talking through this proof. Now we got to show like why that is.
VT equals QR,
Then TS should equal RS, right? So we got to like go through and show why that is, all right? So we had 3 pieces of given, right? They're only going to pull out the first 2 for now. Then they address the third piece of given in step 3, okay? But they start us off with the 2 midpoint things, and they say that that's given, great, okay? Now, if we have that this guy is the midpoint, okay? Then they say that QR is going to be congruent to RS. That's what this guy comes from,
Is that transitive?
okay?
Is it definition of congruence?
And nope, it's not definition congruent.
Definition of
If this guy's a midpoint, then that's true. If this guy's a midpoint, then that's true.
midpoint definition.
This is midpoint theorem. Midpoint theorem. Or I would have taken definition of midpoint. That's fine. Midpoint theorem. Okay, that is like the third one we wrote down. The one with the star, right? If they say that it's a midpoint, then those 2 sides are congruent. That's the midpoint theorem, right? Okay, so there is that. Then they pull out the next piece of given information. They wrote that down. That's given, right? Okay. But now we want to, let's look at these 2 steps right here. I've boxed them in green, and I want to figure out how to combine those in such a way to get this. Substitution. So if we look at QR equals VT, and I want QR is equal to VS, VT somehow transformed into TS. How can I transform VT into TS? VT is congruent to TS, so I took TS and I've shoved him in there, right? So it's substitution. Substitution. Okay? Those are all done. Yes, I haven't pulled them apart yet. Okay?
Symmetric.
All right. Now, the symmetric property is the reason for this next thing, and it requires me to take something and flip it. But, like, I don't know which one of these things I'm flipping. Am I flipping this one? 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 Like, which one am I flipping? Right? Like, I have to flip one of them around. Okay, so here's a strategy that I use. Sometimes if I get stuck and I'm like, I don't know what to put, I look and work backwards. Okay, so here's the deal. I need to use the transitive property to get from this spot, right? Which means that this was my first piece and this was my third piece. So in other words, I had at some point RS is equal or congruent to something, and something is congruent to TS, right? I have RS is congruent to something and something is congruent to TS. Well, right here I have something is congruent to TS. So what's my question mark part?
What is congruent? Or what is QR?
QR is my question mark part, right? Do you see how that works? I have that QR is equal to TS, and I know TS has to be my last spot, so that must be my middle piece. So I need to state, this is the part that's missing right here. RS is equal to QR. Do I have RS is equal to QR?
No.
I have QR is equal to RS, but I need RS is equal to QR. So can I take this guy and flip him?
Yeah.
RS is congruent to QR, and that is the symmetric property. I flipped him around. Okay, so let's see how this works. Whoop. Whoop. Okay, we are using the transitive property. Again, that's like the skip over the middle guy, right? But the transitive property, we're reading step number 5 before step number 4, right? So if RS is equal to QR and QR is equal to TS, then is RS equal to TS? Yes, that's the transitive property, okay? But it went backwards in order, which is fine. We could go step 5 and then step 4, but that's what we have to have, right? And that's that transitive property, okay? Sometimes it's weird things, okay? Sometimes you have to work backwards a little bit if you can't quite see what's going to happen. All right, last thing. They have on example 3, Marcellus is planning a birthday party. He measures a length of ribbon for a balloon. Here's my length of ribbon. Whoop, that length. And then he uses this ribbon to measure and cut the second ribbon. So I pull a ribbon out and I cut it that length, right? Then he uses this length to get the next length, right? Then he uses this length to get the next length. And then he uses this length to get the next length, and he keeps doing it for 10 more, right? Now, I would not recommend this. My prom kids that are getting ready to start decorating for prom, I would not recommend this thing. Because sometimes my second ribbon gets a little bit shorter, and then my third ribbon gets a little bit shorter than that, right? So what's the best strategy to use?
Just keep using that first.
Keep using the first one. You measure everything to the first one. Does that make sense? Right? Because even if you screw it up, it's not going to like make it go smaller and smaller and smaller, right? Or bigger and bigger and bigger, whatever, right? Okay. But let's assume that he measured exactly perfectly, right? And this one matches this one, and this one matches this one, and this one matches this one, and he does it for 10 times. Is the last ribbon that he cut the same length as the first ribbon?
Yes.
If he did it right.
Yes.
Yes, it is the same. Now, why? Because the first one will be equal to the second one, and the second one will be equal to the third one. So the first and the third one are the same. And then the third one will be equal to the fourth one, and the fourth one is equal to the fifth one, so the third one's equal to the fifth one, and then the first one's equal to the fifth one. Does that make sense? What's that called? That's a transitive property, right? It like keeps skipping all the way through until you go to the 10th one. So the transitive, yes, by the transitive property. Transitive property means that they should all be the same because each one is the same as each other, right? Got it? Got it?
That's all we had to do.
That's all you had to do. Yeah. That will be like 5, 6, 7. 2 and 8 are going to be your proofs. Okay? So, try the best you can on those. We will go over the two, we'll go over any questions, I guess, tomorrow, but we'll go over the 2 proofs for sure tomorrow. So if you get stuck, just go through each thing. Even if you get stuck on a line, try to figure out what the next line should be, right? Like, so fill in as many of the blanks as you can, and we will go over those proofs tomorrow, probably. Unless we do it at the end of the period, which I don't think we'll have time, but that's fine. Okay? So tomorrow we'll go over proofs before we do the mid-chapter quiz. Okay? Good? Questions? 5 homework problems. Okay. I said 5 homework problems, and Holden was like, yeah, but number 2 has 8 parts to it. I'm like, well, yeah, kind of. 8 blanks to fill. Well, yeah, number 2. This is number 2. This is number 2. 8 blanks to.
I know, so that's what it's only that 3 questions.
Sorry.
Why did they put
Sorry.
Yeah.
What? I don't know, because then you have to write over the question mark. That's silly.